Good morning, students. Today we will start first topic of Physics 1. The name of the topic is rotational dynamics. In rotational dynamics, we are going to study what is circular motion. Let me explain what is circular motion. I have written over here. Physics deals with the various types of motion. Out of various types of motion, the motion is called circular motion, is a special case of motion in which particle revolve along a circumference of a circle. You will see here in the diagram, if I take a particle, it revolves along the circumference of a circle. Such motion of a particle is called circular motion. Let us take some examples. The first example of circular motion is motion of the earth as well as other planets around the sun. Second example is what? Motion of an object tied at the end of a string and whirl in a circle. And the third example is a motion of a tip of a minute hand, hour hand, and the second hand of a clock. Such motions we observe is a circular motion. Students, in the exam, 2 marks question will be there. That is what characteristic of circular motion. The first characteristic of circular motion is accelerated motion. What do you mean by accelerated motion? If I observe the diagram, you will find that object which is what revolving along the circumference of a circle, we observe that the direction continuously changing. That's why such circular motion is called accelerated motion, because direction of the velocity changes at every instant, and that's why it is called accelerated motion. Second characteristic of circular motion is periodic motion. Periodic name itself, it repeats the same path after a particular interval of time. That's why circular motion is a periodic motion. This is 2 marks question. Students, now we will study some kinematics of circular motion. Kinematics means some parameters or some quantities to describe a circular motion. Students, the first characteristics or first parameter is radius vector. For that, I will consider an object which is what moving along the circumference of a circle of radius r in anti-clockwise sense. We observe here, if body is at point A, the line joining between center and the point on the circumference of a circle is called a radius. The vector now is a radius vector. It's not a radius, it's a radius vector. Vector means what? It has direction and magnitude. Then this radius vector or this radius has some particular direction. The vector drawn from the center of a circle to the position of a particle on the circumference of a circle is called radius vector. So students, what is the radius vector here? Is a OA bar. If I consider a point B, so what is the radius vector, students? OB bar. So from diagram, we observe that OA bar is a radius vector. Second kinematics or second quantity of a circular motion is angular displacement. What do you mean by angular displacement? First, let us consider the diagram. Let us understand the diagram. If initially object will be at point A at time t equals to what? 0 second. After a particular time t equals to t1, object move from point A to point B. When object move from point A to B, then we observe two radius vector, that is what OB bar and OA bar. The angle between OA bar and OB bar is called angular displacement. So what is the definition of angular displacement? Angular displacement is defined as the angle described by whom? Radius vector in a given time. What is the time over here, students? T1. So from time 0 second to time t equals to t1 second, whatever radius vector makes an angle, that angle is called angular displacement. Students, let us derive some formula for angular displacement. As we know, what is the total angle of a circle? We know the total angle of a circle is 360 degree. When we say radius vector covers a total angle of 360 degree, so that object will move along the circumference of a circle. The total distance covered by the object is what? Circumference of a circle. Now students, object move from point A to point B. What is the angle made by the object with respect to center? Is what? Theta. So now question is what? What is the path covered by the object when angular displacement is what? Theta. So let path covered by the object be what? S. So students, we will cross multiply. So 2 pi multiplied by S will give us equals to theta multiplied by 2 pi r. What is our question? We want to find what? S. That is what? Path. So what is path here? We observe that 2 pi get cancelled. So what is S equals to r theta? You have seen this formula at the length of r in 11th standard maths. Students, let us consider the formula for, let us make the formula for theta. What is theta therefore? S upon r. What is the formula for theta? S upon r. Students, if I consider small this change in angle, then there is a small change in what? Path. So this is a formula for in terms of what? Vector. Students, one more question examiner will ask. What is the direction of angular displacement? Students, direction of angular displacement is given by right hand rule. What right hand rule states that? It states that imagine an axis of rotation to be held in a right hand with the fingers curl around it and the thumb outstretched. If the curved fingers gives the direction of the motion, the students, what is the direction of motion here? Anti-clockwise, and thumb is outstretched. If fingers gives the direction of the motion of a particle performing circular motion, then direction of the outstretched thumb gives the direction of angular displacement. The students, remember that is the direction of angular displacement. Hope so you understood two quantities of circular motion. Let us study two more quantities in the next lecture. Thank you very much.